A stationary observer measures a rod moving at 0.943 C. So U is 0.943 C to be 27 meters long. So the stationary observer is measuring this distance while it's moving. Okay, so that's not the proper length. That's the L, or the length observed, to be 27 meters. How long will the rod appear to be when it comes to rest? So we want to know, what's the proper length of this rod when it is at rest? Okay, so here's the equation that we have. We have this equation in two forms, but I'll just write the one that's solved for the proper length, since that's what we're looking for. So L over square root of 1 minus U squared over C squared. So L, 27 meters over square root of 1 minus 0.943 squared C squared over C squared. So the C squareds cancel. And I'm going to do a little algebra here, or a little, not even, little calculation here to solve for LP. And when I do this, I get about 81 meters, which is answer choice C. And that would make sense, right? Once the rod's not moving anymore and we can measure its proper length, we measure a length closer to a much larger length, right? So think back a handful of slides to that image that showed the sphere at velocity equals 0. And then as it got closer and closer to C, like 0.9 C, it was squished and much shorter. The rod is just like that, okay? So when it's at rest, we see the full length of the rod, 81 meters. But as it moves faster and faster and faster and faster, in this case at 0.943 times the speed of light, it's much shorter. In the case of this example, we would observe it to be 27 meters long.